In the second part of 5.5, we're going to continue to look at graphs of relations and functions. So here's an example. The graph shows the number of fishing boats anchored in an inlet in the Queen Charlotte Islands as a function of time. Identify the dependent variable and the independent variable. Okay, well, the dependent variable is always the x-axis, it's time, and the independent variable is, the independent variable is time with the x-axis, the dependent variable is the number of boats. Question B says, why are the points on the graph not connected? Okay, well, they're not connected because that would indicate that there are going to be partial fractions of boats, okay, and there aren't, you can only have whole numbered boats, so that's why there are separate dots on this graph and the graph is not joined. And the question C says determine the domain and range. So the domain, we're just going to list all of the elements. So it looks like 9 o'clock is 1, 10, 11, 12, 13, 14, 15, and 16. 10, 11, 12, 13, 14, 15, and 16. The range would be my y values, and it looks like I have 6 as my smallest, 8, 10, this dot here would be 11, 15, and 25. So those would be the sets of the domain and the range. Okay, this graph shows the approximate height of the tide of h meters as a function of time at Port Clemens in Hawaii on June 17, 2009. Identify the dependent and independent variables. So again, the independent is time, the dependent is the height of the tide. Why are the points joined in this graph? Because this is a continuous function. There's always going to be some tide at any particular time. So this one here, we join them because it's a continuous function. Part C, the domain and range. So the domain now is not going to be a set of values. It's going to be an inequality. And my domain is going from 9 to 16. So it's going to be 9 is less than or equal to t less than or equal to 16. And again, I'm using t because my time is my x-axis and it says it's t there. The range is the variable h. And the range is going from, it looks like 0.9 all the way up to 1.5. So 0.9 is less than or equal to h is less than or equal to 1.5. All right, here's the graph of a function, negative 3x plus 7, written in function notation, which we talked about earlier. And the question is saying, determine the range value when the domain value is negative 2. So basically they're saying, what is the y value when x is negative 2? Well, at negative 2, I travel up here and I hit the graph right there. And that would be halfway between 12 and 14, so that would be 13. Question B says to determine the domain value when the range value is 4. So in other words, what is the x value when y is 4? Well, when y is 4, the x value is 1. All right, I want you to pause the video and give this one a try. Okay, so here's the graph of the function g of x, which is 4x minus 7, and we want to determine the range value or the y value when the x value is 3. So when x is 3, the y value is right about there, and that appears to be about 9. Question B says determine the domain value when the range value is negative 7. So when the y value is negative 7, that's right about there, and the domain value would be negative 1. Okay, so there is the end of section 5.5, graphs and relations. So give those a try. And again, check the answers on the website if you need help.